hydrophobic materials work is the topic I chose. Why I chose hydrophobic materials as my topic. My original interest was sparked when I saw how rain and ski gear repelled water. I wondered how this was possible and why these materials did, but others didn't, like cotton. The definitions in Greek stems are pretty simple. Hydro means water, and Phobos is the Greek god of fear, so it means fear. The opposite is hydrophilic. Hydro still means water, philic means having attraction to, so hydrophilic means being attracted to the water. The chemistry is pretty simple. Water is extremely polar, and it wants to form hydrogen bonds between other molecules and other polar molecules. A molecule's hydrophobicity is determined by the level of how nonpolar it is. If it's too nonpolar, it will not have hydrogen bonds. The inability to form hydrogen bonds means that the water is repelled. You might see this with water sticking to itself. This is called beading. This happens when the water would rather hydrogen bond with itself rather than with the hydrophobic material because it's not possible. And you can see this in the photo on the right. You can see the beading starting to form, the conic cloud, and the black material at the bottom, which is not forming hydrogen bonds with these water molecules. So there are many real-world applications. The most prevalent one would be water bottles. Most people use a water bottle almost every day. Water bottles are made out of metal typically, and metal is almost always nonpolar. And then also there is a hydrophobic coating within most water bottles that also protects from germs. Second is kind of what sparked my inspiration for this, and that is the rain clothes and umbrellas. Umbrellas also protect from the sun, but it's very important that both of these are hydrophobic so that they don't get the person wet. That's the entire point of them. And then third would be windows and glass. Most people will see windows and glass in their cars or their houses, so it's also important that these are made hydrophobic. And then you will see the beading a lot on this, maybe in the shower, maybe on your car's windshield, or on your house's windows after it rains, but that's where most people would be familiar with beading from. Here's the demonstration. In front of me, there are 5 things. We're going to see if they're hydrophobic or not. A way we can tell is if there is any beading, if the water goes totally off of it, or if it is absorbed. You can see the water does not absorb, but rather it goes off the side. Second, the paper towel. The water is absorbed by the paper towel. You can see that it is not hydrophobic, and its main purpose is to absorb water, not be hydrophobic. Third is a jacket. And you can see that this is very hydrophobic. You can see all of the beading, meaning that there's not hydrogen bonds forming between the material and the water, but the water rather is forming its own hydrogen bonds. Third is a ski jacket. And this is slightly hydrophobic, but if you see, it actually does absorb into the jacket once it's there long enough. And last is this Brophy shirt, and this is not hydrophobic because the water absorbs into the shirt. So as you can see, the paper towel and the Brophy shirt were hydrophilic more, and the gray or rain jacket and the water bottle were hydrophobic because it went off the side, or you could see the beading on the gray jacket. And then the green jacket would be a sort of in between. It is pretty hydrophobic, but quickly enough the water will start to seep through, so it's not fully hydrophobic. So in conclusion, hydrophobic materials are everywhere and utilized in all areas of life, like with most people, water bottles, glass, and rain gear, umbrellas. And then chemistry is simple. Nonpolar molecules are unable to form the hydrogen bonds with water. And understanding hydrophobic materials has helped us to fix problems and can continue to. Thank you.